Okay, so now we want to talk about adding and subtracting rational expressions with unlike denominators. So let's start out with basic fractions. If you had 2/3 plus 3/5, we know in order for us to be able to add or subtract fractions, we must have a common denominator. These do not have a common denominator. So our first step would be to find the common denominator, which would also be the least common multiple of 3 and 5, which would be 15. Now when I add and subtract fractions and I have to get a common denominator, I like to write my problem vertically, because I'm going to have to write an equivalent fraction for each of these that has the common denominator that I chose. So in this case, my common denominator is 15. So I come out beside each fraction and write an equivalent fraction with a denominator of 15, and I will have to figure out what these numerators are going to be. I say 3 would have to be multiplied by 5 to give me 15, and whatever I do to the bottom of the fraction, I've got to do the same thing to the top, and so that's going to give me 10/15. Now if you think about this, you need to understand that 10/15 is equal to 2/3. We've just written it in a different form with a different denominator. If I reduce 10/15, it would reduce back to 2/3. Multiplying a fraction by the same number on top and the bottom is like multiplying it by a form of 1. 5 over 5 is just like 1, and when you multiply something by 1, it doesn't change its value. So even though this looks different, this is equal to 2/3. Alright, down here I would have to multiply 5 by 3 to get 15. And again, whatever I do on the bottom, I need to do on the top. So that's going to give me 9. Then to add these, I would add my numerators. My denominator stays the same. I have 19/15. I'm not worried about the fact that it's improper. That's okay. I would simplify it if I could. In other words, if there were a number that would go evenly into 19 and 15, I would reduce this by dividing the top and bottom by that number, but there's not. So for this problem, I'm finished. Now, we're going to do very similar steps to this for rational expressions that have variables and polynomials in them. So let's look at one like that. If I have 4 over 7k plus 3 over k squared. Okay, again, I don't like my problem to be horizontal. I want to write it vertically so that I can write my equivalent fractions out beside each of these. I first need to find a common denominator, so I'm going to do that right here. Alright, my coefficient part in each denominator, I have a 7 and a 1. The common denominator for those would be 7. The highest power of k that I see is k squared. So my common denominator is going to be 7k squared. So over here, I'm going to fill that in the denominator for each of these. And then I have to figure out what the numerators would be. So I look back here and I say, what did I multiply 7k by to get 7k squared? I would have had to multiply it by k. So whatever I do on the bottom, I do the same thing on the top, so that's going to give me 4k. Down here, I would have had to multiply the k squared by 7 to get 7k squared. I'm going to do the same thing on top, and that's going to give me 21. I'm then going to combine my numerators. Now 4k and 21 are not like terms, so don't try to combine those and tell me that it's 25k. This has a k on it, this doesn't. So by combine those, I mean just put them together in the numerator. 4k plus 21 over 7k squared. Now, our next step, and I'm going to write the steps down for you in just a minute, but our next step would be to factor anything that we can possibly factor, and that would lead us to see if we would be able to simplify this at all. But nothing will factor in this, and so we are finished. This is our final answer on that problem. Alright, so let's see. What if we have 2x minus 4 over 3 minus x plus 1 over 2. Okay, again, we have got not the same denominator, so we need a common denominator. This isn't too bad because my denominators are just numbers, so I would just get a common denominator for 3 and 2, which would be 6. Now, here's something important I want to point out to you. A lot of times in doing these problems, when we have a subtraction problem and we have to write equivalent fractions, we kind of forget about that subtraction sign. It gets left over here, and that can be dangerous and make us make mistakes. And so what I'm going to show you is what I typically do. If I have a subtraction, I go ahead and change it to addition and distribute that subtraction sign through the numerator of what's being subtracted. And that way, when I move this over here, that sign won't get left behind. Okay, and that sign does affect everything in the numerator of the fraction that's being subtracted. Alright, so if my common denominator is 6, I can see up here that I would have had to multiply that 3 by 2 to get 6. That means I need to multiply the top by 2. Now this is a binomial, so when we multiply it by 2, we'll have to distribute that 2 through that binomial, and that's going to give us 4x minus 8. Alright, down on the bottom, we see we'd have to multiply that by 3. Same situation here, we've got a binomial, we're multiplying by 3. I'm going to distribute that 3, and I'm going to get negative 3x minus 3. Alright, now when I combine my fractions, I'm going to combine like terms in my numerator. 4x minus 3x is 1x, or just x. Negative 8 and negative 3 makes negative 11, and I'm going to put that over 6. Now if anything would factor here, I would try to factor it so that I could simplify, but it won't on this particular problem. Alright, let's do another one. 5 over 3a squared b minus 7 over 6b squared. Okay, again, if it's given to you written horizontally, the first thing that I would suggest you do is write your problem vertically. Again, I see that we've got subtraction here, so just to be on the safe side, I'm going to go ahead and change that to addition and put the negative sign on the 7 so I don't lose track of it. Alright, my least common denominator for these two, for 3 and a 6, it's going to be a 6. As far as my variables go, it's going to be the highest power of every different variable that I see in the denominator. So I've got an a squared, and the highest power of b I see is b squared. So my common denominator is 6a squared b squared. So I'm going to come out here to the side, and I'm going to make my equivalent fractions with that denominator. 6a squared b squared. Alright, so now I need to figure out what's going to go in the numerator here and here. On the top, I see that I would have to multiply that by 2 to get a coefficient of 6. I have all my a's, but I'm also missing a b to make b squared. So it looks like 2b is what we need to multiply by. We'll multiply that on the top as well and get 10b. Down here on the bottom, I've got the 6, I've got the b squared. What I'm missing is the a squared. So I'm going to multiply the bottom and the top of that fraction by a squared, which is going to give me negative 7a squared. Alright, I'm ready to combine, and my numerators don't have like terms in them, so I'm just going to put them together over the common denominator. If I could factor anything here, I would, to see that if I could simplify, but it doesn't look like I can. Okay, so I'm going to now give you a list of steps we're going to follow, because as we get into more difficult ones, these steps are going to becomes super important. So if you want to pause the video and write those steps down, I'm just going to I kept them on a separate piece of paper so I could continue to use them on each sheet that I do. So let me present you with another problem here. I've got 1 over x minus 5 plus negative 10 over x squared minus 25. Now, I'm going to use these steps to take me through this problem. All right, so step 1 says factor the denominators if possible. So I check these denominators out. I have not had any in any of my previous problems. See, all of my denominators were monomials. So nothing could be factored. They could be broken down into smaller pieces, but not as far as factoring a polynomial goes. But now we've got some polynomials. So we're looking at these to see if we can factor. X minus 5 cannot be factored, but x squared minus 25 can be factored. That's the difference of squares, and it will factor to x plus 5 times x minus 5. Okay, now that we've done that, we need to find our least common denominator. Well, our least common denominator is going to be a product of the highest power of every different factor. Well, we have x minus 5s, we have x plus 5s, and the highest power of those that we see is just the first power. So we're going to need one of each, an x plus 5 and an x minus 5 in our common denominator. And we do want to keep that in factored form like this. So when we write our equivalent fractions up here, our denominator will be x plus 5 times x minus 5. Now if you notice, this second fraction already has that as a denominator. So if the denominator doesn't change, the numerator is not going to change either. But up here, we had an x minus 5 as the denominator, which means we multiplied that by x plus 5 to get this. That means we have to multiply the top by x plus 5 as well. This is just 1 times x plus 5, so that's going to be x plus 5. All right. The next step, we did this one. Rewrite fractions with new common denominator. That's what we did here. We multiplied the numerator out, and we left the denominator in factored form. And now we're going to combine the numerators and put that over the LCD. So when we combine our numerators and we combine our like terms, we're going to come out with x minus 5 on the top over the common denominator. All right, we look at our numerator, we factor our numerator if possible. It will not factor. And then we see if we can simplify. Well, we can, because we have these like binomials on the top and the bottom. And that's going to leave us with a simplified form of 1 over x plus 5 as our final answer. Okay, let's try another one following all of those steps that we just put out right here. All right, this time we're going to have 3a minus 7 over 6a plus 10 minus 10 over 3a squared plus 5a. Okay, step 1. Factor your denominators if possible. So check your denominators here. Up top, yes, I see that I can factor out a greatest common factor of, just kidding, 2. That's going to leave me 3a plus 5. And on the bottom fraction, I can again factor out a greatest common factor of a, which is going to leave me 3a plus 5. Okay, so now when I look at all of those factors in my denominator, I know I have to have the highest power of every different factor that I see. So I'm going to need a 2, I'm going to need an a, and I'm going to need a 3a plus 5. So that's my common denominator. So the next step is to rewrite fractions with the new common denominator. Well, the new common denominator is 2a times 3a plus 5. 2a times 3a plus 5. Okay, here the denominator has a 2 and a 3a plus 5, but it's missing the a, so that's what it got multiplied by, which means I have to multiply this numerator by a. I need to distribute the a through that binomial. That gives me 3a squared minus 7a. And I almost forgot, and this is so easy to do, when you've got that minus, let's go ahead and put it right here on this 10 so it doesn't get lost. Alright, here in my denominator I have an a and a 3a plus 5, so it looks like I had to multiply that by 2. So I'll multiply the top by 2, which is going to be negative 20. Alright, then we'll combine our numerators and put them over our least common denominator. So we'll have 3a squared minus 7a minus 20 all over our common denominator of 2a times 3a plus 5. Alright, step 5, factor the numerator if possible. Well, we're going to have to give it a try. It's got a leading coefficient other than 1, so I'm going to use the AC method. Our A is 3 and our C is negative 20. We multiply those together. That's negative 60. We look for factors of negative 60 that add to get negative 7. Those will be negative 12 and positive 5. So we split that middle term into negative 12a plus 5a. We bring that first term down just like it is. We bring our last term down just like it is. Now all we've done here is we've rewritten this trinomial into a polynomial with 4 terms. And the point of doing that is so that we can group. Alright, out of the first group we can take a 3a. That'll leave a minus 4. Out of the second group we can take a 5, which also leaves a minus 4. And then these have an a minus 4 in common that we can factor out, which will leave us with 3a plus 5. So that is what our numerator factors to, a minus 4 and 3a plus 5 over 2a times 3a plus 5. So we see once we factor that we do have some like binomials that will cancel, and we're left with a minus 4 over 2a as our final answer.